Good evening, everyone. Shall we start the session?
Yes.
Yeah, we'll start. Okay. Good evening, everyone. Uh, Welcome to the live session for the third week on the course of Statistics for Biomedical Engineering. I am MD Ashit Raja, PMRF Fellow, and that is Director Chapalli. And this is some short biography for about myself. And we'll talk about like in the first week we have seen if anyone have the doubt so you can start like you can like start asking like now also, or you can speak like you can that you can ask now also. And if we talk about the first week, so first week we have discussed about what is the actually statistic, and how that become the biostatistic, like if the application will go into the biomedical or medicine, so it will become biostatistic. And we have discussed some few cases also. After that, like why do we need the statistic, and in the statistic, what is the role of probability? That also we have discussed. In that descriptive, we have seen what is the qualitative and quantitative. That descriptive and statistical, inferential statistic, and that all we have seen. In the third week, like we are going to continue of the descriptive statistic, and then we'll discuss more of the more that is the mean, mode, and then um, median. That thing we have discussed in the last class also. So now we'll continue from there also, and then we'll introduce the starting like a probability. What is the role of probability? With that also we'll see. Then some sort of distribution, and then we'll see what is the expectation, like how it different from the mean, and then expectation. Then after we'll see sample that variance and then population. And after that we'll see the like we'll try to introduce some sort of inference statistic, or maybe we'll stop at the that is the probability that is distribution. In that, if you talk about the probability distribution, so we have a different types of distributions are there, like we have the binomials are there, maybe the Bernoulli trials and all are there. Then we have the Poissons are there, and we will discuss like in detail to do, like we'll go very slowly, and we can have the interactive session, like where we have to use the Bernoulli like the binomial distribution, and then where we have to use the Poisson the distributions. And after that, once we'll finish it up that discrete that distribution, then we'll go with the continuous distribution. In the continuous, we have the normal distribution that is very important in the throughout of the statistic course, or even though if we have that application in the machine learning engineering, or if you're going to deal with the statistic in any field. So the thing, it's going to be more or like it's a real time application. It will be going to comes under the um, normal distributions only. And if we talk about the exponential, we have that's also having some sort of limitations we have. Then we have a one standard, or maybe the fundamental, that is the uniform distribution. That's also we'll see. And for each distribution, we'll see what is the expectation, what is the mean, like that is the variance. Based upon that, we are going to see the further statistic. Why we are more like when we're going to introduce to the statistic, like the question will come, then why we're discussing more that is the probability and all. So that is a very important part of the, because when we are saying any statistics, so this is chances of the occurrence, and that is all totally interconnected with the probability. So that we have to discuss, or we should be very clear about that is the probability. Because if we talk about the event, we sometimes will be having that independent event will be there, sometimes we'll be having that that is the exclusive event will be there, and then we'll be having some dependent that event will be there. So before applying to the any of the application for the statistics, so that we should know that what type of event is happening. If we don't know, let's say that some event is happening that is totally independent, and if you're going to apply some statistic, so we'll not get the inference. We'll get the inference, but that inference will be not the correct. So that's why we should be knowing the idea, like We should have the idea like what type of event are there. Based upon the event only, we can go with the any of the inferential statistic. Or if we talk about the let's say like some events are the, if we don't know the distributions, let's say sometimes the distributions is something different, like normal distributions is there, that's okay, because many of the statistic we have to uh, assume that like that distribution is the what you can say normal distribution. If that condition is going to violate, so we have to know that what type of distributions are there. That if that is that non-normal distributions, maybe that Bernoulli distributions or Poisson's distributions and all are there. So we should have the idea what is the criteria, what is the properties of the particular distributions, and what will be their expected mean or the absolute mean or the variance how it's varying, because the sample mean, sample variance, and then population mean and population variance is totally different, even though it will be the close, but the inference will not going to get the proper way. So now so the first 2 week we have seen the some basic, and then we have seen the probability and all. Now we'll jump bit of more into the probability. We'll see the what is the probability and all, whatever events are there. After that, we'll see some sort of distributions. We'll see, and then we'll move further ahead, and then we'll solve slowly. Like we'll solve some more and more problem. So we'll try to understand like what's happening and all. So I think this part I have seen already. Like when we saw about the probability, probability is something like it's the measure of the likelihood of the an event is occurring. Let's say I'm going to toss the coin. So for the toss the coin, there will be like either it will come head and tail. I'm not bothered about whether that particular things is independent or that is what we can say dependent. Now we are just thinking like what will be there, what is the event, and what is the, just 1 minute. Okay, so we'll be having just we'll be having if any event is occurring, so what is the probability, what is the likelihood of the an event that is going to occur. Let's say I'm going to toss the coin, so there is chances that it will either it's going to be a head or tail, so that is the event. Okay, so what is the probability, so that we have to calculate, so that is the case will comes under the probability. So if you talk about the what is the event, even something that is our out of interest. Let's say I'm going to roll the dice. So dice, there is just six chances are there. Either one, either two, either three, either four, either five, either six. So all six are event, and that event is independent of each other. The similar case like let's say toss the coin. So either that is going to be head and then tail. Okay. So it's something like event, something that our interest or something that is going to happen. Then after we are going to see like the probability will be the either the worst case will be the zero. Let's say if something is going to happen, so there is some chances something will be there. That is going to happen. That is not the case of zero. That is going to impossible. Let's say I'm going to there will be rain. So we'll say either 0.0001% or 1%, or either we'll say 50% or the 60%, or the 60%. So it will be going to be like all either they. So for the for the case of that is the probability, the zero will be the impossible, and the one will be the certain. Let's say I told okay I'm going to that place, so there is chances that I'm going to 100% sure that I'll go there. So that is going to be 100% probability. But the zero will be not if I'm showing going to say something happen, something going to happen. Let's say I'm going to take the admission based upon some sort of rank. Let's say I have qualified the gate, some sort of rank, some sort of gate score, and then corresponding gate that is a gate score is there, and that we have the rank also there. So we'll now we are going to predict, or we have the chances like for this particular score or the rank, this particular college I will get it. So there will be chances will be there. So that can't be the zero. Okay, that will be that I'm not saying the absolute zero, but it will be chances like for the IITs. Let's say they have the cutoff of 700, like 700 or 800 something. If going to be second case or second college, second tier college, maybe the NIT, that not second tier college, like I'll say the second stage of the college. First is the IIT, then we'll go to NIT and all. So it's going to be like some sort of occurrence chance is there. So miss, so that is going to be probability. So if we talk about the types of the probability, so firstly the theoretical probability that will going to be based upon the logical that is the reasoning. In that we're not going to quantify any numbers and all. We'll tell okay based upon either it's something is happening, something is not going to happen, or empirical probability. It's going to be based upon the experimental data. When we have the subjective that is the probability based upon the belief or some sort of experience will be there. So now we'll come to the if when we're going to say the probability, we're going to define like a let's say for any event that is going to happen. So let's say for the event, let's say event is happening like this. So and total number. So that is the chance of occurrence of that particular event will going to happen. So in that case, let's say we have the population. In that, like we have to take the event or sample space. So event is something that is our some sort of the outcome, or the sample space will be the our population. Sample space will be the our population. It's like all possible outcomes will be there. So if that will say that we will say let's say we'll say the population. So this is the orthodox, or we will say the fundamentals of the that is the rule of the probability. So there will limits of the that will be the either 0 to 1. So that is the, for any event that is going to happen. So there will be a non-negative, like what we can say. That will be the always none, like that is the none that is negative probability for any event. And if you talk about the summation of all the sample space, it's going to be always one. It can't go beyond of one. Any case, let's say something is going to happen for the head or tail. So for the probability of the head is the zero point 0.5 and probability of the tail is the zero point 0.5. So summation will be the always one. Okay. So again, we'll not discuss whether it's going to follow the linearity and non-linearity. That we'll see when we go into the what we can say distributions and all, because they're going to follow something that the mean will going to follow the this property, but the variance will not going to follow the uh, non that is the linearity property. Then we have a P A union B. P A union B, if it is going to be a mutually exclusive event, so it's going to P A plus PB. And if you talk about the PA, for a general case, the PA plus PB minus P of intersection B. So this is the one term, like it's going to be like happening. Let's say we have the event one, second one event. This is the A, B, and this will be going to be like intersection. So that is going to be like that is the Venn diagram. Okay. So for a like I want to like for the overall what is the probability? So we have to individually calculate the PA plus PB. So 1, 2. Then we have to subtract this the what is the common probability. So we'll get the actual what's happening. Okay. So this is some basic of the probability we'll see like discuss. So that I think I have discussed in the last class already. Like that is the last session. And after that, we have to see like the conditional probability. Conditional probability means with the terms itself. What do we mean by conditional? Let's say any of the insurance company and all they're going to offer some sort of insurance. They'll say, okay, the terms and condition applies. They're going to like that thing will happen. I will going to cover your terms. That is the insurance or maybe the what we can say vehicle that is insurance. But they have the certain terms and criteria. So similar way in the probability also we have the conditional probability. Let's say I am saying we have the A, B, C sample space are there. We'll say what is the probability of A that already the P already occurs, or what is the probability of B when already A and C already occurs. So that particular case we are going to say the conditional probability. So because this is going to be a like very important in our statistic, or even though if we're going to study the probabilities also. So we should be knowing that how the things are happening, because there is no because the in the that applications or that we'll be having in the real life and all, will be not going to be like that all the event is going to occur independently. Understood? Just let's say some independent is going to occur independently, so means that we can't based upon that parameter we can sometimes will not able to tell the inference there about the population, because that will not give the clear picture. They'll be always they are going to be interconnected with the one event to the second to the third. So when it is interconnected, so we should be knowing that like what is the probability once that for a particular event when the other two events already occurred. So in that case, whatever the case, what is the chances of that event is going to happen? So that we should know that. Okay. So in the all possible outcome that may constitute a subset of the total group. Sometimes it's going to happen. So let's say I am saying I have the two events are there A and B. So what is the probability of A that B already happened? So in that case, P A intersection B and the probability of the B already happened. In the similar case, you can do like this. That is the probability of B when already A that happened. So in that case, when any of the event already occurred, so that can't be the zero. So that will be the if that is going to be zero, it's going to be an impossible case. If it is zero, if it is zero, so that is the impossible case, means that event did not happen. But in the case of probability, like that is the probability. So that case already happened. So for that case, that will be going to be always non-zero. If it is zero, means that case was not happen. Understood? Similar way, P of B means probability of the B event when all that is the A already occur. So in that case, P of A intersection B or B intersection A, both are same upon P of A when subjected to probability of A is not going to be of 0. So this is the concept of the what we can say conditional probability. So this is actually that you might have all going that have gone through that. So I will not go solve the problem based upon that. We'll solve the problem like whatever the terms will comes into the inferential statistic and all. Like we'll solve about the mean or the expected mean or the variance or the expected variance and all. With that I will going to discuss more and more. Before that, before jumping into the expected mean and all, we will discuss distributions also, because the distribution is going to be more important actually. Apart from that, what we'll discuss the absolute that is the probability. Okay, I think the today session will go a bit of long, like we'll go with the 2 hour exactly, and we have the plenty of the problem we have to solve. We'll solve the problem on the Poisson, will solve on that binomial, will solve on the maybe the for the normal will solve in the coming classes. So now we have seen the conditional probability. So now we have the joint by the name of joint itself. Sometimes we want to find the probability that is subject to pick a random from the group of subject possesses two characteristics at the same time. Okay, two characteristics that's going to be occur at the same time. So in that case, let's say one box is there. In that, like let's say the black ball, the red ball, the green balls are there. So now what we want to let's say for the ball, probability of the ball, either it can be that is a black, red, or green. If you're going to pick one ball, if you're going to pick the two balls, three balls, it can be either way. So it's going to be like if you're going to calculate the combined properties of that, either the ball will get. If I'm going to say either, it means either black, either red, either the green. Okay. First case will be three box black, red, green. In that case, if I'm going to say so, there will be obvious chance that is the black ball, either the red ball, either the green ball. If it is going to mix it up, so again, if you're going to, so it can be of either black or red or the green. So if I'll say okay, the what is the probability the ball was black, red, or red, green, something like this. So it means that we have to calculate the joint probability for the both event that is going to occur at the same time. Whenever I'll say the one ball, it means either a black, either red, either green. If I'll say that I need to collect the two, three, four, five ball, so there is a plenty of the possibility will comes into the picture. Understood? Then after we have the multiplication rules also there. So multiplication rule, if we talk about in the algebra, let's say this is the ax plus b. So AAX plus B. So the similar AB. So that the similar rule here is going to also follow based upon that. But the thing is that their probability it's going to be different. Like that is the probability computed from the other probability. For example, a joint probability may computed as the product of the appropriate marginal probability. Again, the concept of marginal probability. Anyone have the idea what is the marginal probability? Marginal probability. Let's say that x or y event is happening in the x direction or in the y direction. If it is going like this, second case, so it's this is going to be total. So let's say this is the event a b, and something will happen. So if it's going to in the x direction or in the y direction, so in that case I'm going to calculate for the probability of x a, probability of x event for the case of b. So if in for calculating that particular probability, that we have to that probability will going to say the what we can say the marginal probability. But there will be a question will come again whether the conditional probability and the marginal is same or not. That is the both probabilities are different. Conditional is something like one event that already occurred. Now second event that I have to go and calculate. But the marginal is something I'm saying like okay, I have that particular case of conditions, but I have to calculate simultaneously for the other event also. So means there is no chances or there is no guarantee that another event that already occurred. But in the case of conditional, so that another event should be it's going to be complete or already happened. It means that it become the past. But for the marginal, there is no guarantee that is going that already occurred. So that is the some sort of slight differences are there. So that we should know that like why it is different from the other probability and all. So I think this also I will not go and solve the problem, but will you should have the idea like how both are different from the one probability from the another probability. So when we'll talk the conditional, so that I told one event that already occurred, it means it's become the past for that particular event. But for the marginal, there is no guarantee that it not happen. It might be happen, it not happen also. So in that particular case, if you're going to calculate the probability, that will become the that will become the marginal probability. So then we have that additional rule. Additional rule, like the similar way, when we are going to follow that algebra case also, here also we have to follow that one. So this rule, P of A union B, that I already told, P of A, P of B minus P of A intersection B. So this is the like fundamental example of what we can say that addition rule. Okay. So now we'll talk about the independent event. Independent event, can anyone tell the example? Like this is the fundamental event that is going to happen. Anyone is there? Can you please answer for that independent event? Anyone?
So that means one event has no relation with other event.
Yeah. By the name itself, that independent mean like one event is going to happen, but it's not going to affect the other. So let's say we have the example of tossing a coin. So once we are going to toss the coin, either head or tail, something will happen, but both are not independent. Let's say that it happens, so tell that is not in the another event it will happen the tell, or sometimes it will happen the hit again. So means this both independent, both event are independent. Okay, so in that case, both the event is going to be independent. Like there, the probability that is not going to affect the another one probability. Let's say something happen. Let's say for a rolling a dice. What is sample space? One, 2, 3, 4, 5, 6. If I'm going to roll the dice, either one, either two, either three, either four, either five, either six. So probability of the each will be the 1/6, 1/6, 1/6, 1/6, 1/6. So means both are all are independent. So that particular event will say independent event. And can anyone tell the like exclusive event, mutually exclusive event, whether the independent event and the mutually exclusive are interconnected or same, or both are different?
Independent, both are same.
I think the both are not same actually. When we'll say the mutually exclusive is like some event that happen, there is nowhere the connection will be like one event P of A that's taken from one sample space, P of B taken from some sort of another sample space. If we talk about the independent, something from a same sample space, but the event there is occurrence of the event that is going to be independent. So in that case, the that particular event will be the independent. But if we say the mutually exclusive means one event like this, second event will be like this. Okay, so there is no connectivity or something. So that particular that both event will become mutually exclusive. But in a single sample space, let's say it's a head or tail. So for the occurrence of this particular event and this event, there is no connection. But the thing is that in the same sample space, but for mutually exclusive, that will be the always like there is no overlapping, or what we can say. Okay, so there will be no overlapping or common grounds will be there. So that this is the most fundamental things like you should be knowing that when the event, whether that independent or mutually exclusive and all. Because if you're going to independent, so probability of A when B already happened, so it's going to be probability of A. Why? Because there is no relation, or like both are independent. So we are not going to touch about that particular things. Similar way, probability of the B when A already happens, it's going to be probability of the B itself. So in that case, probability of A intersection B become PA into PB. Okay. But in the case of mutually exclusive event, probability of intersection A intersection B will become 0. Okay. So means both are like totally like exclusive. There is no way connections. But in the case of independent, like there might be a same sample space, but the event that happening, there is no connection is going on. So that's why we should be knowing that like what is the independent event, what is the mutually exclusive events and all. So this is the fundamental question that everywhere if you go somewhere like interviews also, let's say that you are going to apply for the bioinformatics course or maybe that post and all, any company or maybe that any IITs or NITs they're going to, so they will ask the simple fundamental questions itself. They will not going to expect you like you should know and that whatever that is a advanced concept you have, you should have the idea, but you should be very clear about the foundation of the statistic. Once you are not clear about the fundamentals, you can't comment on any of the event or any of the statistic or any of the inference from the things you will get from the basics. So now will come, let's say now we'll solve one problem with there. In a certain high school consisting of 16 girls and 14 boys. So means we have the A, let's say G is the 60, B is the 40. Then it is observed that 24 girls and 16 boys wear the glasses. This is the second, what you can say, conditions we have. If a student is picked at random from this class, that is the probability of the class that the student was the wearing glass was the 14 by 100 because the 24 into 16. So that is the probability of that student wear the glasses will be the always 14 by 100. It's going to 0.4. Is it clear? So now they're asking what is the probability that a student pick at a random wear glass given that a student is a boy. But in the case of that, just tell me the what is the event actually. Just tell me. It's a classic example of conditional probability. How they are asking, they're asking the student pick at random wear eyeglasses when the student is already boy. So in that case, probability of E, like any event when the boy is already there, what will happen? Probability of E intersection B upon probability of the boy. Is it? Tell me. So for that particular case, we have the only 16 out of 40. What will the probability of the boys? That student is the boy. So for total overall probability will be 14 upon the 100. Is it? So means they know that I am going to pick a person or pick a student that is the boys means. So we have the idea there will be chances that probability of the boys in a whole sample space will be the 40 by 100. So that is the one probability. Now they are saying a student wear a glass. How many students are wearing the glasses? So 24 girls, 16 boys. So now we have the two options. Either we can go with the 24 or 16. Now they're saying now things are here is a boys. So means 16. 16 boys out of 40 boys. So 16 by 14, this will be the like the event I want to predict, or maybe that I want to get the chances of the occurrence. Okay, then after among of the all boys, among of the all boys, like let's say like we have that total boys and girls are there. Among of that chances of the probability that going to boy, it's going to be a 14 by 100. And in that also, this event already I am told, like I'm saying that this event I'm going to pick from there. Then after in that among the boys, 16 boys is going to wear the glasses. So 16 by 14 by 14 by 100. So what will be the answer? 16 by 40 into 100 by 40. Is it? So these two will go 16. Can anyone tell like what is the things? 16 by 100 and then 14 by 100. Or 16, no, it's 16 by 100 actually. Sorry for that. Don't get confused. Like just say, they're saying look, the students with the glass, then they are not going to specify like from which sample space. So that for that particular case, the sample space will become how much? Because the 16 and then 14. Then after the what will the probability? So in that case, so it will become a 14 by 60. So that will become like zero point 0.4. So what is the second case? What is the probability of a joint occurrence of the event of the wearing eyeglasses and then being a boy? What is the probability of the joint occurrence of the event of wearing eyeglasses and a being boy? Can anyone tell the answer for this? Anyone? It's a joint occurrence. It's going to be, but the both are independent event. Both are independent event. 16 by. So this is the case. I think that hopefully this example will be clear.
Yes, yes.
So now we'll come to the complementary event. Can anyone tell what is the complementary event?
So the sample space outside the given event remaining.
Uh, yeah, the sample space, like in that, like whatever the event occur, what will be the remaining? So that will become the complementary of that particular event. So as we all know that the probability of any summation of all the probability will be the always summation of probability will be the one for a particular event. P of A something is there. So P of A bar that will become the complementary one minus whatever the event that already occur P of A. So this is the complementary event. Okay, so that is going to help in like whenever we'll solve the normal distribution problem, like sometimes we will not know the value of the from the chart, and then we'll have to go from the other side and all. That time we're going to use. So now we'll discuss like a marginal probability. That again I told like whatever that how I told conditional and then marginal, almost similar but not always same. Okay, so given some variable that can broken into the M category, let's say A1, A2, then AIM, then it becomes the joint occurring variable that is broken into the another category with the BI. I told that X, Y, A, B. So in that case, if you're going to take the cases, so for that particular case, it will become, but in the I case, in the J case. If you're going to summation, it's going to be something will come, but the thing is the summation will be the always one, but it's going to be marginal. If you're going to calculate for that particular conditions, so that will become the that is the marginal. It means that we are going to take the simultaneously, means jointly occurring. This is the keyword here in the marginal. But in the case of conditional, so that occurrence that already happened. So that is the key difference between the marginal and then conditional probability. Okay, so this thing will see in the case of this probability, we'll see when we're going to solve the problem for the ANOVA or maybe the chi-square test and all. We'll see. So that test, so that picture will come into the picture. So there we will see in the detail. Then, so now we'll come to that. Now we have discussed the basic of the probability. So in that also so we'll be having the variables will be there. So can anyone tell the what is the random variable? Random variable. Uh, Random variable is nothing like, let's say if some event is going to occur or some event is going to happen, some random outcome for a particular experiment. If we are going to that particular experiment or the outcome, if we assign, if we assign some sort of value, that is a numerical value. So let's say I'm going to toss the coin, head or tail. Okay, that the head and tail is going. So that head and tail, like it's a physically or descriptively we know, or maybe the qualitatively know. If you're going to assign some sort of some the weight or the numerical value, so that will become the random variable. Because when we're going to discuss any in the statistics, so we have to discuss the quantitatively, not the qualitatively. Let's say some the pain is going to happen. Pain. So pain is like again we'll say that pain is going to be mild or maybe the low, the severe. So that's again become the physical, again the qualitative. If the same pain, the parameter I'll set on the scale of 0 to 10. So 1, 0, 1, 2, 3, 4 to till 10. So that will become the random variable for the particular case. But before that, pain label. So this I told it's low. This I told severe. So associated to this label or associated to that, what we can say that outcome will going to assign some number. So that number will become the okay for that particular event. It will become the random variable that the variable for an experiment when we're going to apply for a that any of the inferential statistic or something that we're going to apply. So that is a random variable is a variable associated with the random sample. Random sample will be the some sort of event. That event can be of anything, maybe the qualitatively or maybe the physically something. If you're going to assign some variable, maybe the numbers or anything, so that will become the random variable. What is the probability function? Can anyone tell? Probability function and then probability density function.
So it is discrete. No?
Yeah, tell me.
It is for discrete. No? It is also the PMF. No? This one.
Yeah, it's a probability mass function. Actually,
Got
whenever that I'm not saying that is for what it is going to use for. Actually, what is the physical that is a inference. Probability mass function or density function, it's going to represent the energy or something like they're going to represent the overall picture of that particular event. Okay, let's say I'm going to say like any event is going to occur 1, 2, 3, 4, 5, 6. So if you're going to define in form of functions, they're going to represent the whole discrete that set of outcome or the event. Okay, so that particular, if that is going to related with the discrete, so that will say probability mass function. If the same thing that is going to happen in the case of continuous distribution, let's say time, temperature. So for that particular to specify in terms of area under the curve, the margin or the volume and all, so that we will say going to continuous random. So it becomes a probability density function. It's going to representation of the whole set of outcome of events. Okay, so this is going to again that is going to useful again when we talk. We have to calculate maybe the that the distribution or expected mean or maybe the expected variance and all. Okay, so this is about the like distribution. So as I told that distribution will be the again one is the discrete, second one is the continuous. Two, if you're going to represent whole sort of discrete uh, event or that is the outcome in a single form or single equations, that we are going to say probability mass function. Or if the similar cases we have the for the continuous variable, let's say the temperature, maybe the volume and something is there, so that will going to represent with the probability density function. Because for the temperature cases it's going to start, it's going to peak. If you're going to will not heat it, it will come down. So this will become your continuous event. Let's say that any of that then number of times the person is going to wait, or then that the number of times the a vehicle pass through a checkpoint, or maybe that a total number of that the waiting hour in a hospital. So that will become like a discrete event. So to if you're going to represent this particular event in the form of any single equations, that will become the probability mass function. For this particular event that is continuous, so it's become a probability density function. Okay, so I think that the distributions are clear. So now when we once we'll go into the any of the health science application and all, so there is always chances like I'm going to say that drug or maybe testing was there. So there is chances that their efficacy we are going to measure it, or we are going to do the screening of the test or diagnostic criteria. Sometime what will happen, sometime what will happen, like if you do the testing and all, if it is we told that should going to make the positive effect for the particular case of any drug, it's going to make the positive effect. We took the test, it came the positive effect, positive. So it's going to be true positive. So means whatever I expected, that the result came into the that fall into that particular category. So this became a true positive. But there is chances of the false positive. What? When the results occur when a test indicate positive status, but the true status is going to negative. What happened? There is a chances that that drug will be not going to effective for that particular set of sample space, but that particular test is showing the positive result, but it should not show in the actual cases. What happened? It's showing the false positive results. Similar way, if I'm going to predict it's going to be a negative, once we have done the testing, it came out to be negative. So it means it's going to true negative. Okay, means something is going to happen, but I told that one negative, or it that is going that is going. Let's say I have that given some drugs to anyone. Drugs means some sort of medicines and all. So I told like this is not going to affect too much. There will be no side effect and all something. But it I told that for that particular drug, I told it's going to negative results. But the results also turn out to be negative. It means true negative. But the thing is that our things should like when the results is going to show the positive, but the true status is going to negative, so it means true negative. No, that's going to false negative. So this thing also we'll discuss in the case of when we have to discuss the confusion matrix. When we talk about the classification accuracy, true positive, true negative, here false positive, false negative, and then this is going to be like solve a confusion matrix. So that there also we'll discuss. So let's say this was the true, and this will become the false. So this is going to be this case. True, if become negative, so this is going to be like that is going to true negative. So now we're going to whenever we have to when it's going to talk about the any test or statistics, so we have to discuss some sort of some question. Like let's say that given that a subject has a disease, what is the probability of the positive test result? Means presence of the system, like a symptom. So that is the application. That is the few cases that I told in the first week we have discussed. Similar way, in the biomedical, like we have to discuss or we have to answer some sort of queries. Let's say I'm going to make a device that's going to measure the heart rate. We have the smartwatches and all. So now the things is that whether the particular results are giving the positive way or not, or maybe what will be the threshold when the how much change will come, and then what if the change threshold limit I kept very low. So what will happen? They're going to show the fluctuation in the outcome. Okay. So, what will be the peak or maybe the threshold limit for to quantify any the heart rate and all something like this? Then after, given that that subject does not have the disease, what the probability of the negative test result? Again, the absence of the system. Then, given a positive screen test or the present of the system, what is the probability that the subject has the disease? That's going to be going to second case, like third case. Then, given a negative screening test result, means there is no absence of system, then probability that subject does not have the diseases. So again, this is the case of like what is the probability there is no absence of system, like absence of the symptom. There is no symptom. So what is the subject what is the probability that particular disease is not going to happen? Let's say in the some cases in the corona also there were no symptom and all, but some people was having the corona also. So something if you're going to take the screen test, so that thing also need to be taken care whether they have the diseases, so whether they have the particular symptom or not, whether they don't have the diseases, whether symptom was there or not. Again, we have to check it. Sometime what will happen? Some person have the diseases, but the symptom will not show. One cases. Some person doesn't have the diseases, but they have the symptom of like cough, maybe the temperature rise and all. Still, that particular COVID was not there. It's just a flu. So this is the possible question can come when we are going to deal in terms of the statistic. So that's why it is very important. Like we should be answer all possible outcomes. We should not stick to the any single outcomes or event. We have to discuss all possible outcome that will comes into the picture. Okay. So now I think we have seen that the random variable. That the random variable is like I told that the what will be the number of sales in a month, in a week, or the same day, or the number of calls. Let's say a call center is there for the hospitals. They are receiving the number of calls like for the appointment, maybe to the follow, or maybe to asking the availability of the doctors and all, or maybe the people in the lines. So these are the all event will comes into the discrete random variables. If we talk about the continuous random variable, it's a length. When the time passes, what will change in the length? Let's say I'm going to elongate the rubber. When we're going to increase the force, like we are going to pull it down. So with the time also passes. When you're going to apply the increase the force, that the length is also increasing. It's not going to be discrete. It's going to be a continuous event. Then the similar case we have the depth also. Then the volume also, then time and weight. So these are the all event we have the what we can say like what we can say we have the continuous distribution. What about the cumulative distribution? Anyone can tell? Cumulative distribution. I think last class we have seen what is the cumulative. Anyone? Last class we have seen the cumulative numbers of frequency. Let's say for a particular the 0 to 10 we have the 10. This is the n. This is the event. Then after 10 to 20 BH, we have the 30. 30 to 40, we have a 20. 40 to 50, we have 30. What is the cumulative number or cumulative frequency? It becomes the 10. Then that the next one will become the 10 plus 30. It will become the 40. 40 plus 20, it becomes the 60. 60 plus 30, it will become the 90. So this will become the cumulative. Cumulative. If you're going to add one more column, cumulative properties or distribution. Let's say for this particular event, we have the point 0.1. Like probability is the point 0.1. For this, we have the point 0.2, point 0.1, point 0.4, 4, 2, 6, 7. This one we have the point 0.3. So point 0.1, the next one will become point 0.3. This will become the point 0.7. And in the last, eventually it should become 1. Understood? So it's going to be like overall cumulative probability distribution will be the always 1. It's not going to be beyond of 1. So sometime the people will tell in terms of cumulative that is the probability that the distributions also. So if we talk about the frequency, so it's going to simply add the event. If we talk about the cumulative distribution, so point 0.1, then the next point 0.3, point 0.7, then eventually it will become the point 0.1. So it's going to be a summation. Like it's going to overall, eventually in the last, it should give the 1. There is not going to that the beyond of 1, or maybe the less than of 1 also should not be there. It should be always 1. If it is going to, it's going to be, if it is going to less than that 1, it means that is the distribution that is the probability is not correct, or it should come 0.99999, it will come, but it should come closer to the 1 itself, eventually 1 itself. Okay, so this is the concept of cumulative distribution, that is the probability. We have to, sometimes it will be the more convenient to work with the cumulative probability distribution of a random variable. So that's also once will come into the examples and all that we can see. Okay. So the same thing what I explained actually. We have the one program frequency that the total number is there. If we talk the cumulative frequency, so 16 plus 47, then summation of this one, then summation of this one, then it this one. Similarly, it will come here also. So if we're going to cumulative here, so we have to, first one will be the 0.288. Second one will become the 0.0288 plus 0.1582. That the next similar way it should come in the last one itself. Same example, nothing like it. I just want to show the cumulative itself. Now we'll come to the, now we have discussed the random variable, and no, we have discussed the random variable, what is the distributions and all. Now we are going to say the mean or expected mean. Can anyone tell the like the difference between the mean or population mean or sample mean? The sample mean is nothing like expected mean. Can anyone tell the difference? How come it's going to impact, or which mean we should take when we're going to solve any statistical problems and all? So whenever we're going to solve a random variable, something, so that we have to take the expected mean. What is the expected mean? So that particular value and corresponding probability. If we talk about the sample mean or population mean, it's going to be like x1 plus x2, x3, x4 till xn by n. So this will become the population mean. It's going to be like absolute mean. Okay. In that, we're not going to say whenever there is a uniformly distributed probabilities are there. If the distributions are uniformly, in that case, population mean or sample that mean will become the same. If the distributions are not going to be like like the uniforms, in that case, this mean will get whatever will get. That is not going to coincide with the expected mean. How come that also that you can take any examples and all, then you can correct and all. Okay. So means if the distributions are uniformly distributed, like for a each sample or for each event, the weight is same. It means for that particular case that the expected mean or the sample mean is going to be same. But if the chances or of occurrence is different for the each event, what will happen? So their expected mean will be the different. It's nothing. X is the same summation or px. Px is nothing like a probability. Similar way, we can calculate the what we can say the variance. The standard deviation will be the sigma square. Okay. Then it's going to be like calculate the x minus mu square into px. Okay. It's going to be like x minus. So this is the error. This is the actually error. X minus mu. This mu, we're going to calculate from where? Expected mean. This is the what is the sample. This is going to represent the error. Then corresponding, we are going to apply the probability. So means Px is the relative frequency of a given random variable. The standard deviation is simply positive square root of the variance. So now will come, I think the part of expectation or the random variable, I think it's clear. Can anyone tell like a variance of x? What will be the formula for that? I think this is the same formula or a variance of x bar. What will be there? Variance of summation of xi by n. Is it? I think I will not go that much of detail in this portion because expected things and all that you can see in the case probability books and all. But the thing is that this will going to help you when you're going to solve the problem in the case of what you can say the t test and then that ANOVA and all. So now we'll come to the probability distributions. So now we have discussed the whole, we have talked about the probability and all. So now we'll go into what are the types of the probability distributions. As we all know that distribution, we have the two types. Is it? One is discrete. This one is the continuous. For discrete, we'll be having some distributions. For continuous, we'll be having some distribution. For a discrete, what we have, what you can say, it's a binomial. For discrete, we have a Poisson's. Then after that, we'll be having a for continuous, we have a normal distribution and then exponential. Other than that, in that we have the viable distributions. Then the chi-square distributions, that will not see because in the statistic we'll be having only a binomial or either the Poisson's. Then most of the cases will be having the normal distributions. So whenever I say when a random process or experiment, call it trial. Let's say I'm going to take some sort of tossing a coin. So it become a trial. First trial, either head or tail. Second trial, either head and tail. So that particular will say, and that is a random process will say it's a trial. Can it's going to be result one of two mutually exclusive item. So dead or alive. If it is like mutually exclusive item, so dead or alive is like sick or well, full terms or that the premature, the trial called that the Bernoulli trials. It means it's going to be like all it's going to be like mutually exclusive. In the case of that that is a head and tail, sick and well, it's a toss that just the tossing of the coin. For a Bernoulli trial, like just see for the case of Bernoulli distribution, we should know the what is the Bernoulli trials. Bernoulli trials is nothing. We have some sort of following conditions. Each trial in one or two possible outcome. So in a binomial distribution, there will always be two outcome will be there. Either yes or no, either head and tail, either sick and well. So that is the case with in the other cases there might be multiple outcome can be there, but the trial will be in n numbers. In that also the trials will be the limited to the particular number. If the trials are that the trial numbers are more, so it's going to fall under the different categories also. If the trials are more, so there is a possibility will be the less. Okay, or maybe the if that we have the less number of no like if the numbers of trials are less, or no, it's like something like we will say like we have a chances of occurrence is going to high. So in that case the number of trial will take the low, because we already know that, like let's say anywhere in a student, or in a college the faculty ratio we have, the student ratio we have, if you're going to take the random, so it will be going to high chances that it's going to be like case of student. Faculty will take some time. Like I'm saying, in a college we have the 5,000 people are there. In 5,000 we have the 4,000 student, 500 faculties are there, 500 we have the staffs are there. That is the non-teaching staff. If we take any of the event, that will go, if I don't take any random person, there will always a high chance it's going to be a student. Why? That the number of some, like the peoples are more, the probability of that student is more. It means we're going to pick that particular students only. So in that case, for this particular, we're going to apply the binomial distributions and all. I will tell you where to apply for the Poisson distributions also. So probability of the success denoted that P remains a constant trial, and the probability that the failure will become the 1 minus P. It's always obvious, we know that if a success or failure. So if it is X is the success, so Y will be the 1 minus X will be the failure. So this is the Bernoulli conditions. And the trials should be the independent. Again, the case of binomial distributions, the trials will be the independent. The outcome of the any trial, it's not going to affect the another outcome of the trials. So this is the conditions of the Bernoulli process that's going to apply into the binomial distributions. So now we all know that what is the binomial distribution. Px will be the ncx p to the power x q to the power n minus x. It means this is the success, this is the failure. So how many trials we have, like n, then what is the event of the occurring that's going to occur, x, then p to the power, like success trials, what that how many that number times happen, then q, p to the survival. So number of success is 0. So n c 0 q to the power n minus 0 into p like p to the power 0. Then 1. Similarly, n to n q to the power n minus n p to the power n. So total will be the always 1. So for a binomial distribution, it's going to be like n c x p to the power q n minus x. If you talk about the mean, what is the mean? Anyone? Then variance. I think here. Mean will be the n of p, number of trials into their corresponding probability. The variance will be npq. A standard deviation will be root under npq. Now I think we can solve some problem also based upon this. Shall we solve, or shall we go to the next part? Let's say I'm saying like I have done toss the coin 10 times, and in that 4 times head occur. So what is the chance of probability of that head? Something like this we'll say. So we know the probability of head will be 0.5. Probability of the tail will be the 0.5. Okay. So n is the 10, c x is the how much, 4, e 0.5, and we have to know that what will be the probability it's going to head. So means like it's going to 4 times 0.5 into the 6 time. So now calculate, so we'll get the probability of getting head. This will your probability. This is a simple example, and the similar you can take for the another example also. So I think the binomial is clear. I think I should not spend too much time on the binomial, is it? Hello, shall I go ahead?
Okay, same.
Yeah. So I think till now so far it is clear, na? What I have discussed.
Yes, sir. Yes.
Yeah. Okay. So now we'll go to the Poisson distribution. Okay. If the x is the number of occurrence, some random event in an interval of time or a space, the probability of the x will going to given in some sort of p of x will be e to the power lambda to the power x by x factorial. It's like a lambda is equal to n of p. It's in that case n will be too high. High means, and the probability will be the always very low. When the number of trials and all it's very high, in that case we are going to use the Poisson distributions, because in when I'll be saying like for a particular time that much number of vehicle passes, but that the probability of getting caught it's very less. Let's say at a checkpoint that the vehicle is passing, number of vehicle is going to pass too much. It's going to pass. Let's say 1,000 vehicle pass in the 1 hour. But what happened? That vehicle got caught one or two. Means corresponding to the number of vehicle pass, that vehicle got the caught by the police. It's very less. It means the probability is very low, but the number is high. So in that particular case, we are going to apply the Poisson distributions. Means number of sample or number of trials is high, but the occurrence or chances is low. In that case, you can apply the Poisson distributions. Or if we talk about the binomial distributions, when we say the tossing of a coin, it's a 50-50 chance. Or we are going to roll a dice 1 by 6, 1 by 6.3, it's going to be like how much? 0.15, 0.16 time. So it's again some chance, but in this case, there will always it's going to be a probability very low. So, and one more thing, that the Poisson distribution is the limiting case of the binomial distributions. I will not go into the derivations actually. You can go to the book. That one book is there, probability and statistic. Like in that, they'll be going to deal more and more for probability than the statistic. Okay, so then the Poisson's process also, the occurrence of the event will be the independent. Again, the terms will be the independent event will be there. Because when a vehicle is going to pass through any checkpoint, so another vehicle is going to also pass. But there is chances of the like something will happen, but both vehicles are not going to be interconnected. That the one vehicle pass, that is independent. Second, that the vehicle pass also, that is also independent. Okay, so means that occurrence of the event will be the always independent, and occurrence of the event is going to happen in the interval of space or time, has no effect on the probability of the second occurrence of the same or any other interval. So means theoretically an infinite number of occurrence of the event must be possible in the interval. Any finite or infinite number can be happen. The probability of the single occurrence of the event in a given interval is going to be like, it's going to be like some that the proportional of the same interval or maybe the other interval also. And if it is infinitely small proportion of the interval, the probability of the more than one occurrence will be the almost negligible. Okay, so now I think based upon this we can solve the problem maybe. Okay, shall I solve one problem? A car has, let's say, I will write. So a car has firm has two cars which it hires day by day. The number of demands for a car in each day is distributed as poisons with lambda is equal to 1.5. Then asking to calculate the proportion on which first one neither car is used. Second one they are asking some demand is refused. Can anyone solve this problem? Given lambda is equal to 1.5. So we all know that P is equal to x e to the power minus lambda power x. So we all know that lambda is equal to 1.5 given. So first one is that what is the first case? Neither car is used means x is equal to 0. Is it correct? So
Yes,
in
sir.
that P is equal to x is equal to 0 e to the power minus lambda the power 0 into x factorial. X is what? 0. So this e to the power minus 0.1.5, this will be the answer. Is it correct? Second one, what they're saying, some demand is going to refute. So how many car they have? They have two car. In the what case they are going to refuse the car? When the demand of the car is going to increase, like it's going to more than 2. It means P of x greater than equal to 2. Correct? Not equal. When it is equal, it's going to be like perfectly higher. They can't refuse the demand. Is it? So, similar case, we can write 1 minus complementary event, 1 minus x less than or equal to 2. In that case, P of x is equal to 0, P of x is equal to 1, P of x is equal to 2. So now you can calculate the x is equal to 0 that we know already. Then x is equal to 1 put here, x is equal to 2 put here. We'll get some final answer. So I think this example is also clear now. Is it?
Yes, sir.
So now we will see now till now we have discussed the discrete distributions. Now we'll go into continuous distribution. So the first is the non-negative function. It's called the probability distribution or the probability distribution density function of a continuous random variable. But the total area bounded by the curve or x-axis is equal to the 1. It's something that it's a very generic term. When we're going to say like this, so that total area should become 1. Okay. So this will say continuous distribution. Nothing is there, something like it's something that we are going to talk in the interval or the space. That's all. So now we'll talk about the uniform distributions. Uniform distribution is something like they are going to divide in a equally distributed. Let's say we have the C to D. C to D. So there the one terms will be the 1 by D, that D minus C. So if you're going to talk about the probability between the A to B, in that case, what will happen? Probability of A, X, B, A to B, this one, that will be that particular event. Then the total event. How many total event is there? D minus C. Just think about the A to B probability I need. So that area, if you calculate, so B total area, then this E, this one I need. So B minus A, this one. Okay. Then the total event, how many we have? This is the case of C to D. So this is the D. Then from here, it's a C. So this event will become D minus C. So this is the what event or what is the my interest B minus A upon that is D minus C. For this, mean will be C plus D by 2 because D, C, there the mean will be somewhere here. And the standard deviation will be D minus root under 12. I think once you will solve the derivations, you will get the idea how this standard deviations or the variance comes into the picture. So this is the uniform distribution. That the uniform distribution is a continuous distribution. Understood? The only thing there will be it's going to be continuously or uniformly distributed. So this is the classical example for a continuous distributions. But when we talk about the in the real time, or maybe that in the practical that the scenario, there is no chances or there is no guarantee that you will get a uniformly distributed. Sometime it's going to be skewed on the positive side, maybe the negative side, or the peak will be somewhere high, peak will be somewhere low. So we have to get into the some sort of what you can say in the real time distributions. For that, we have the sometimes the exponential distributions also there. We have the normal distributions also there. Something like so. Now we'll discuss about the normal distributions. In the normal distributions, it's also called as a Gaussian distribution and then bell-shaped distributions also told us. So it's going to be approximately many situations. Means it's going to be like give a real time application. Okay, and it's going to perfectly symmetrical around its mean. So one conditions is there for the normal distribution. It's going to be perfectly symmetrical around the mean. And sometimes, like whenever we are going to solve the problem in a real time or any real time, for example, first we are going to assume the data is the symmetrical about the mean, or maybe the normal distribution is there. But what happen when the data is more sophisticated or significant and all? So in that case, just 1 minute. So when the data is the real time, or maybe that when the features are more, variables are more, in that case the data will be sometimes skewed either side. It can be positively skewed or maybe the negatively skewed. So in that case we have to solve the real time, so that data will be the non what do you say, non normal distributions. Okay, for that we have the different testing will be there. For the normal distribution we have the t-test, ANOVA is there. But once we'll come into the what we can say like non-normal distributions, when the data is the non-parametric, so we have to go for the non-parametric test and all. We have to say. So normal distribution is going to like define in terms of x and then mu and sigma. Like it's going to be like x is the sample, then it's going to be mu and sigma. Mu is the mean and sigma is the standard deviation. So fx is equal to 1 of root under 2 pi sigma e to the power x minus whole square plus 2 sigma square. Okay. Or and this will be the case of the limit will be minus infinity to infinity always. And if we talk about the what are the characteristic or the properties of the after that, after the normal distribution we have the standard normal distribution, that also we'll discuss, don't worry. So if you talk about the what is the properties of the normal distributions, so that we have it's going to symmetrical about the mean always. It's going to be always symmetrical about the mean. It's going to be minus infinity, it's going to be minus plus infinity, and the curve on the other side will be the mirror image of the other side. So it's going to be like if you talk, this is the mirror. So both are mirror of the mean, median, and mode always will be the equal. Okay, the total area under the curve over the x-axis will be the 1 square unit. Means we all know that the total probability will be always, so that the probability will be always 0. And because of the symmetry, it's already going to be a 50% of the area is to right perpendicular, and it's going to be the 50% to the left. So this is some like fundamental properties are all are there. So now we'll come to the standard normal distributions. Now let's say, because the things are like when we talk about the normal distributions, we have the mu and sigma is the two variable. So whenever we have to integrate it or we have to solve it, so we have to solve into the two variable to quantify this one, and that we have the limit of minus infinity to minus plus infinity. But if we talk about the standard normal standard distribution, it's going to be like in terms of mu and sigma, we're going to take their one terms, it's going to be z barabar x minus mu by sigma. Okay, and the limit will become, so it becomes the mean of 0 and a standard deviation of 1. So it's going to be like the most important member of this family is the standard normal distribution, or the uniform that the unit normal distribution, as it's sometimes called, because it's a mean of 0 and the divisions will be what we can say 1. So in that case, if you're going to calculate, so it becomes 2 pi e to the power minus that is z square by 2, and this will become the mean of 0. This is a negative, this is the positive side, and the standard divisions will be the 1. Now, in the coming classes, actually, we'll solve or we'll discuss more about the normal distributions and all. So now, if we talk about the I think symmetric builds up density function, and if we talk about the single sigma, two sigma, three sigma, I think you might have all heard about six sigma companies, four sigma companies, three sigma companies, and all. Anyone have the idea how it become the Six Sigma, and how it become the more relevant?
No, sir.
Yeah, tell me.
Don't know, sir.
Whenever we are going to single sigma, so they're going to be like margin of error will be the very high. How come? It's going to mu is equal to 0. It's been a 50-50 chance. Either 50% there will be chances of error will be there. If we're going to like talk about the single sigma, one sigma, 60%, 8% of the area. So it means 32% area will be the chances of the error is the very high. Okay, area under, whenever I'm saying area under the curve, it's a probability. It's a chances of the occurrence, or there is a hope that going to 68% of chance it's going to be occur. So then the complementary will become 32%. That will become the error, or means that is not going to happen. If we take the two sigma is a 95% of the area is going to cover. It means that error is got reduced down. Okay. Then if you talk about the 3 sigma, 99.7%, 0.03% only it's the chances of the occurrence. Like let's say I'm going to assign a project to the Infosys or the TCS. If they're saying the 3 sigma company, means there is chances that 0.03% chances that that project is not going to deliver on the time. If any company is saying no, I am the single sigma company, like the company follow the single sigma policy, what's happened? In that case, there is chances that 68% chances is only that they are going to that deliver the product on a time. Means there is like they're going to deliver, but the chances is the 68% only. If a same company is saying I am going to follow the 3 sigma policy, it means they are going to broaden the area or to reduce the chances of the like the error. Okay. So in that case, 0.03%, like they're going like 99% of the time they're going to deliver the product on a time. But sometime what will happen? They're not going to deliver on a time. So that's why 0.03% chances are still there. Whenever, so we have to, whenever we are going to talk about any probability or chances of that, we have to think about the pinch of salt also. Let's say some company now, the TCS is claiming that they are following the Six Sigma policy. It means 99.99999% chances that they're going to deliver the product on a time. Okay. So means there is still chances that 0.00001% chances that they are not going to deliver the product on a time. Means still some chances is there. Let's say they are going to take the product of 1,000 product they will take. Out of 1,000, There might be a chance that they're going to deliver all product on a time, but maybe the one product will be going to get delayed. So still, so that's why as a statistician, you should not be the optimistic like they are saying 99.99%. So they'll give the all things are correct. There is a still chance is that the project might not deliver, or maybe any company or any things they are saying like I have followed the Six Sigma policy and all, and I have administered the drug and all. There is a very less chance of the error. But as a statistician, you have to say no. There is a still chance is there. There is error will comes into the picture. Okay, so you should not be the very optimistic about like that things will get into the completed at the time on the time, something like this. So I think based upon this will solve many more problem. So it will become like how come when we're going to increase the sigma, so there is a chances of the like the non-delivery of the any project or something, it's going to reduce down. Because how come? Because when you're going to increase the sigma, so they're going to cover more and more area. When you're going to increase toward the one area, like when we're saying the probability going to close to the one, it means there is a definite chance is there that particular things will going to happen. So now to solve all these problems, we have the what we can say. What we can say that we have the table also there. Like I think that table you will get in the books and all, based upon the z value and all. Z you will calculate the when the given value x minus mu by sigma. X will be there. Let's say x is something. Then mu, let's say 1 sigma, or that the something some value will be there corresponding to the x. Then sigma will be the 1, 1.5, 2, 2, 2.58 something. So this is the area under the curve. So this is going to represent the accuracy of any of the probability of the chances of the occurrence and all. So I think this is the all about the distributions in the probability, with the distribution in the probability. And in the coming class, like we'll go with the further. Now we'll solve some problems and all. So if we talk about the standardized normal distribution, that's the same thing I told now. Mean will be the 0, sigma will be the 1, area under the curve will be the 1. If it is single sigma, 1 sigma, so 68.3%. If it is going to 2 sigma, 95.4%, it means they are covering the whole area. 3 sigma, they are going to cover the more and more area. Okay, so each normal distribution here are the area distribution under the curve is given. So means when they're going to cover more and more area, so there will be a like more chances of the occurrence will be there. Okay, so now I think shall I recap all the thing and then we'll go solve some problem that is going to help you to solve the problem for your what we can say the use and all. So I think till now I have discussed probability and some sort of rule, or maybe the what means the types of the probability, and also we have seen the addition rule. Then we have to discuss the multiplication rule. Then we have seen independent event. Then we have seen about conditional probability. Marginal we have seen. Then expected mean and variance we have seen. Then we have discussed the distribution. Distribution also discrete we have seen. Then we have seen the continuous also. Then we have seen the probability distribution in the discrete. We have seen the binomial. Then Poisson's. Here we have seen uniformly. Here we have seen the normal distribution. Some more distributions is there in the continuous, like let's say we have the exponential. Then we have the variable, etc. I think this more not like that much relative to the statistic and all. Morely that the mostly will be that is the normal. So we're going to stick. We will going to stick around the normal everywhere. So we'll solve some problems also. So I think till here it's all clear, na? Can we solve some problem based upon what we have discussed as of now? Shall we?
Yes, sir.
Yes.
Okay. So the first question we have a which of the following statement are true for the mutually exclusive event? I think I have discussed. Please tell me the answer for this. You have some 2 to 3 minute time. Okay. I'll just tell me.
Is P, sir,
Sir, yeah. Tell me.
mutually exclusive
Yeah, it's a
A plus B, probability A plus probability P.
yeah. So whenever we'll say mutually exclusive, it means the both independent are totally
Separate,
exclusive. So they're not going to be connected. So that there
exclusive.
is no intersection. It's going to be zero. And we all know that P A union B will be P of A, P of B minus P of A
P.
intersection B. So this will become zero. So P of A, P B. So this option is correct. This option is correct. What about this? This option. This is the case of conditional
Mutually conditional.
conditional probability. And in that also we have that this is the independent one. Is it? Whenever we'll say P of A,
Yeah,
B, it should be P of
A,
A, B upon
A,
PB. But because of that the independent event, so it become a P of A. Because the B, it's not going to affect anything. So it become a PA. So in that also it become a conditional probability, also the independent. This statement can anyone tell? This is the case of independent. So this option is actually for independent event, not for the mutually exclusive. So for this
mutually
particular,
exclusive.
yeah, for this question, we have the answer of A and B. So I think this question is clear. Any doubt is there in this?
No, sir.
Sir.
So now we have the second statement. Second question. Which of the following are always true for the independent event? So you have to see, read the question. Always true, then the independent event. We have the two keyword. Is
Independent.
it?
Sir.
Tell me. What will be the option? So I will write the condition for the independent event.
A and D.
A and
A and D.
A and D is there. Okay, then. So when we talk about the P, A and B.
Four,
Okay, okay, I will just show.
four also.
First option is correct. Is it? Because when the events are independent, P intersection B will become P of A into
In,
P of B. So first one is correct. Second one, the when we have the
correct.
conditional probability P of A intersection B upon PB. So when the events are like there, so it will become PA. It okay. So this also correct. Similar way, P of B
Correct.
upon A. So P of A intersection B, P
A,
of B, it will become P of B. So this event is
B,
also correct, but this can't be the correct
correct.
because we are going to replace these things to here.
It's
So
unique. Okay.
yeah, so the answer is A, B, and C. Okay,
See.
so I think this also very simple question. Any doubt? So if the case will become mutually exclusive, so this can't be the option. Then this is the answer. Other three will be not there. Because that all the case of independent. So this will be the answer for the mutually exclusive. So now the third question we have a random variable is defined as. So now again, just try to what you can say. Think about that. How can we define the random variable?
A function that assigns numerical values.
Yeah. So means it's a variable that takes on the fixed value. Just see the random value can take anyone. Even they can take a fixed value, they can take the variable value. So it's a variable. They can't be always true. A variable can be the fixed or the variable.
Variable.
So this can't be the correct answer. Correct. A deterministic variable.
Yes.
A deterministic that also can't be because a deterministic like something that already fixed is there fixed. So that the random variable can be the can't be the deterministic and a variable that is always discrete. So that variable can be of both. Either it can be a discrete, it can be a continuous. So
Continue.
the random variable is actually it's a process. We are going to assign some sort of numerical value to the event or outcome in a sample space. Or it can be of anything. It can be the fixed value, it can be a variable, or it can be a deterministic. That will be like it's a not always true. A deterministic variable, it's true, but not always true. Again, the conditions. Okay. A variable that is always discrete. No, the variable can be the discrete. A variable can be that continuous also. So means the correct answer will be having the assigned numerical value. So correct option is the B. Is it clear?
Yes.
Third question we have a cumulative distribution function of a random variable x is defined as. Just that tell me. I think that I have discussed this problem. Is it?
B, the answer.
I think
B,
uh,
X equal or lesser.
x greater than x less than x less than equal or x equal to. Just tell me the which is the answer.
Option
B, lesser or equal than X.
B. Okay. First we'll check with the p is equal to
Yeah, I think
x is
so.
equal to x. When we talk about the cumulative distribution function, so it's going to be like mass function. It's not the CDF. This is the p of x is equal to x. It means what is that? It's going to be a it's going to be a like discrete function.
The even
Yeah.
is, yes.
It's not the it's a PMF, not the CDF. Second one, second one will be the always what we can say. Difference of the CDF is actually it's going to be always less than that of what we have the value. If it is going to be beyond of that x is equal to greater than what will happen. Let's say I have p of x is equal to we have the 1, 2, 3, 4, 5, 6. In that case, what will be the maximum possible case can be? Either it will be the equal to 6 or the less than 6 now. Is it? Any event can't be beyond of 7 like
6.
any event can't be like beyond of the 6. 7 can't not possible, 8 not possible, 9 also not possible. Is it?
Yes.
So it's going to be like this will be the not option. This will be the case of the discrete, like it's a PMF, not the CDF. Whatever the fourth case, D. For a continuous like something, so it should be a x is equal to greater than x. It can be true, but for this discrete, it will be a, like this is the case of PMF, not CDF. Okay. So second option is the correct option for the case of CDF. Understood? So now the next question we have a which of the following are the properties of a discrete random variable probability mass function? So again the case of PMF and that too discrete random variable. Tell me what will be the answer? Actually, whenever we are going to say P of x is
A.
equal to the answer, this statement is correct because whenever we are going to say any event, so their probability should be it's going to be non-negative. It means it's a correct now. Whenever I was going to say any of the discrete random variable, so their probability should be non-negative. It means they're asking probability of any event at any like probability of a sample space at any event is a greater than or equal to 0. That is the worst case that might become 0 also, or maybe it should be a greater than 0 means it's a non-negative. So it's a correct option. What about the summation of x of px is equal to 1? It means they are saying because summation of all probability it's going to be always same na. Tell me, it's going to be summation of the properties will be the always one only na. One. No.
Don't know, sir.
Tell me, because whenever we are going to tell probability of the roll of dice, it's going to be 1, 2, 3, 4, 5, 6. It's x. So probability of 1, probability of 2, probability of 3, probability of 4. So actually probability of the summation it's not going to be x in that case. So 1 by 6, 1 by
Okay.
6, 1 by 6, it's a correct. Okay.
Okay, sir.
But what about the third case? Probability of x less than or equal to 1. That statement is not correct. Is it?
Yes.
Why? This is the only case. This is the only case that is going to happen when the maximum value is going to be greater than x, small x.
Yes.
Understood? If it is going to be
Yeah.
like this, so it's going to happen one. If it's 7, it's not going to happen all the time. And what about the p of x greater than x is equal to 0? That is not always true, na?
Nice, sir.
Why? Because if it is, they might have told p of x greater than x is equal to 0, that this is the valid for a one case. But they are saying for all case. That is not always true, na? For some cases, that might be. Let's say I have the x is equal to 1, 2, 3, 4, 5, 6. Let's say probability of x greater than 1. It can come 0, but not for all x. Is it?
Yeah, yes.
So For this question, we have the answer of A and B. I think hopefully this is clear.
Okay, sir.
So now we have the probability density function of a continuous random variable must satisfy the which of the following conditions. Tell me what it will be the answer. First statement is again correct. For any of f of
Yes,
x,
sir.
where things will
It's
be always
correct.
non-negative. And the summation of like sample like interval or something that will be the always 1. This statement is correct. This also correct. This can't be correct. Fx is always constant. Then there is a possibility that all time will get the uniform distribution. That is the probability. So that will not the case of always. So this option is wrong. So the answer for this question we have the A and B. Is it? I think this is a simple question. Shall I go ahead? So now we have the expected value of the discrete random variable x is given by whatever I taught in the starting, like whatever I discussed in the starting, the same thing I'm speaking here also. When we talk about this discrete value, so this is the correct option because mu is equal to summation of x px for discrete, but this is not the correct for
Discrete.
it's for it is for continuous.
Continuous.
Okay, so this can't be the option. P of x is equal to x is a simple probability, not the mean, because it's we are asking the value mean. It's a simple probability. What about this one? 0 of f x f of dx. No. Why? Because that the limit is not correct, and that too is it is for continuous, not the discrete. So this can't be the answer. This can't be the answer. For this will be the this answer. I think this is clear, huh? Shall I go ahead? Okay, so now we have the for a continuous random variable x with PDF of fx, the expected value. Tell me, what is the answer? This is the false case. How come? It should be multiplied with the x. So this is not correct because the limit is not correct and x should be multiplied. It's a simple any of the case of probability. So that can't be the answer. This also the limit is not correct. Because when we are going to talk, I'm not saying anything like about that any limit. I'm saying the random variable. It can be a minus negative to positive negative, minus negative to plus negative. Is it? This is the case of correct case. Minus infinity to infinity x of fx. Let's say f of x is equal to 2x, and we can solve by 0 to x of 2. Just see why I am saying limit is not correct because this should not be limit to the 0 to 1. It can be 0 to 2. It can be 0 to 5. It can be 0 to 6. Minus 1 to 1. Something. So that context it is because they're asking for the. It can be a case for any of the case, but not always. Just try to understood. It's not the formula for the. It's always the limit will be the 0 to 1. This is not always true. But it might be the case of any of the event. That is true. But for the expected for the condition, the variable, that the limit should be minus infinity to plus infinity. Not the fix. We are not going to fix it to the minus infinity to plus no, like from 0 to 1. So that is going to be going to be incorrect value. So let's say for this problem, if you will solve, so that will become 0 to 2, that the limit, and x, if of x is equal to 2x is equal to 2 will take outside 0 to 2 x square x cube by 3 0 to 2, so it become 9 minus 3 0, so it become 3. Just see, the same thing can be 0 to 1 also, is it? So that will become 0 to 1. So I'm saying this formula is not valid for always true, it can be the case. So this is the answer. Similar fourth case is also, it's not, x is not there, and this is the limit is also not correct. So this can't be the answer. So this for particular this problem, this is the correct answer. I think this is clear why I am going to stressing like limit is wrong. Here their context was that the limit will be the always 0 to 1. No, it can be the case of any of the event, but not always. That the always we have to, in general, we have to say minus infinity to plus infinity. Understood? So now we have the properties of the expectation operator. This is the include. I told that expectation will follow the linear property, but the variance not always. I think this I have explained. Just tell me what will be the answer.
A and B.
Yeah, because when we are going to say expectation of ax plus b, so we can take a out, ex plus eb. It's a constant, this also constant, this also constant, so they're going to follow the linearity property. But non-negativity, this also not correct. There is not always chance. So this is not going to for all x. This also it's going to be not correct. This also not going to correct. If you tell I'll going to this is the case only possible when the variance will be going to be a 0. When we tell the e of x square, so it's going to be like e of x uh, square minus of variance of x. Okay, plus of variance of x. So this case is only possible when variance will be the 0. If x are independent, expectation of x will be the expectation of x into expectation of y. So this is the basic property. So for this we have the answer of A and D. This can't be the answer. This can't be the answer. I think this clear now. 10th one. The variance of random variable x is defined as. Just tell me what will the answer.
So option C.
Option
C.
C. Why can't be option B? First one is actually for mean. Second one, it's actually also for variance only. If you're going to expand this one, so it will come in form of like this. C also. So option both in B and C will both will be there. It's a competition form. I'll tell you the one book with the probability and statistic by. I think I have the book. I have the book. Okay, I'll just put the back. Like it's a book by some. I forgot the name actually. That is there in that website also. Can go through. So this, if you're going to expand this one, so this answer will come. So both B and C will be the answer for this. What about the this problem? The probability mass function of a binomial distribution with the variable parameter n and p is? Just tell me. It's a simple trade formula question. Actually, this problem is for what? Poison distribution. Is it? Because they are saying we have the keyword here, binomial. Here, this is the incomplete formula. This is incomplete formula. This is the actual formula. This is nothing a success. This is not a like failure. So for a binomial distribution, this is the answer. Is it correct? Correct, na? Okay, we'll go ahead.
Yes, sir.
Yeah, we'll go ahead with the one more problem. The Poisson distribution is often used to model. Tell me. Now just read it and tell me the problem.
So option B.
If you talk about the binomial, it was
In a
either,
fixed interval of time or space.
yeah, it was a yes or no, or maybe the head and tail. It selected two possible outcome. But if you talk,
Failure or success.
yeah, and if you talk about the poisons, it's going to happen in the fixed interval of time or space. So this is the correct one. This one is case of what we can say number of success in a fixed number of trials. It's again not correct option. Always that will not correct. For the case of binomial also that might be not correct. It's a fixed number, so there might be the correct for the binomial sometime, but not always. So it's a continuous random variable. It can't be because the poisons is actually for discrete, is it? And probability of a single trial. No, it can be that is a multiple trial, 10 trial, 15 trial, 16 trial. So this can't be the always not true. So poisons will be the always in a fixed interval of time or space. It's like just I told the example at a checkpoint in a like a 6 hour, how many number of cars is passing and how many got caught, or maybe for a person to wait to see the doctor in a fixed like 3 hour or 4 hour, 2 hour. It's a span of time they are saying, na. So that is the case of Poisson distribution. Sometimes this Poisson distribution also follow the exponential distributions also, like time to failure or time to meet. So that's also the case will be there. So I think this part is also clear. Like we should be very clear about the basics, like how the things are, where we should apply which formula. Okay. When there is not complicated problems are there that we can solve either with the binomial, either with the Poissons, we can get the answers. But if it become multi-variable, multi-features and all, it become very bit of problematic. Or maybe the numbers of trials will be the high, we can't apply the binomials. So, or the same case, if the number of trials is less, but the probability is very high, so that again that you can't apply to the Poissons also. Okay, so now we have the some problems are there. Let's say continuous set discrete random variable x that represent the number of defective item found in a batch of 5 items. The probability of distribution p of x is equal to 0.1, x is equal to 1, 0.2, then like this is there. Okay, so now they are saying what will be the expected value of the random variable. Can you tell the formula? Summation of x of px. Is it correct? We know the value at the p is equal to 0, 2, 1, 2, 3. So it's going to be like p x into px is equal to 0, x into p of x is equal to 1. Like this till will go x into px is equal to 4. So x is equal to 0. How much is the probability? 0.1. Then 1, 0.2, then 1. We have 0.2 into 0.4. Tell me the answer for this, anyone. 3 into 0.2, 4 into 0.1. What will be the answer for this? Can anyone tell? I think the 2. I think this is a simple one, na? So now the next, when we have the same value, we need to find the variance of x. X sigma of variance of x is equal to, is it? Or either way. I think this is the way, not the first one. Tell me, how will calculate the sigma of x? This one we have calculated already, no? Expectation of x. Now we can calculate the, how come? X square, p of x. Similar way, 0 square p of 0.1 plus 1 square 0.2 plus 2 square into 0.4. Because of the linear property, we can apply 3 square into 0.2. What is the answer actually? Eventually, 1. Can you able to solve it actually? This one. We have to just simply put in the formula. 3 square plus 0.2 plus 4 square 0.1. So we'll get the answer 1. So next we have a discrete random variable. Now we have to find the standard deviation. So standard deviation will be sigma of this one, variance of x. So it came 1.2, so 1.095, so it's going to be answer again 1. Correct? Is it correct?
Yes, sir.
Now we'll go to the next class question we have. They have given the Poisson distribution. Lambda is equal to 3. So they're saying the control engineer is analyzing the number of defects in the product produced by the factory. The number of defects follows a Poisson distribution of mean 3 defects per day. Based upon this value, they are saying exactly 2 defects will occur on a given day. Means x is equal to 2. But we know the value e to the power minus lambda, lambda power by x into x factorial. So x we know now e to the power minus 3 into lambda 3 to the power 2 into 2 factorial. Yeah, tell me the answer. 0.2240 if you calculate. Shall I go ahead?
Okay.
Next is, I think one more question is there. Poisson distribution, there is no defect will occur on a given day. No effect means x is equal to 0. Put the formula x is equal e to the power minus lambda, lambda to the power x by x factorial, e to the power 3, lambda to the power 0, 0 to the power factorial, it becomes minus 0.3. What was the answer? C. Then now that's the last question. They're saying that defect is going to occur more than 3. How much? More than 3. So it can be P of x not 1 of P of x is equal to 0, P of x is equal to 1, P of x is equal to 2, P of x is equal to 3. You will get the answer. Okay. Is it clear now? Because we have that they're saying three different per day only. If it is going to more than three, like it's going to be like we can use this approach and then we can get the answer for this. Is it? I think that's all for
Yes,
today.
sir.
So hopefully the lecture was fine. You are able to understand again. Is it?
Yes, sir.
So I think all things are clear now. Any doubt
Yes,
is
sir.
there?
Yes, sir.
Any doubt is there?
No, sir.
Okay. So thank you. And then next class we will discuss some problem based upon the normal distributions, and then after we'll jump into the inferential
Uh,
statistic like
Sir,
t-test. Yeah.
if we have a doubt with assignment, can we ask over here? Means the corrected assignment of previous weeks.
Previous week you can ask like, but the current week, I think until unless if the solution is provided that
Mhm.
I'm not that
Yeah.
liable to.
Yes, I
Yeah.
understand. Like
Yeah.
previous week means they have given the solution, but I think like wrong, like they have given wrong answer as correct answer.
Okay. Okay. So that thing I think just you ask in the group. I will try to answer there. I think this will be not the good platform to answer here.
Okay, I have already posted in the Q&A section. Yes.
Okay. Okay. 'Cause I'll go and check it and then I'll try to answer there.
Okay, sir. Okay, thank you, sir.
Any other doubt?
No, sir.
Okay. Thank you. And then next week we'll see that normal distribution and then we'll go ahead with the problems. Okay. Yeah. Tell
Thank you,
me.
sir.
Yeah. Okay. Thank you.
Thank you, sir.
Okay. Thank you. Thank you so much.